We are now in the last example of rational expressions. So the last example talks about architecture. An architect designed a fixed stained glass window as shown in the figure. So this is the figure in the left. So we have a rectangular portion wherein the width is exactly equal to the diameter of its semicircle, and the value of it is x. We do not know. And the length is twice the width, so 2x. So we are going to deal with the three different situations. First is to know what are the approximate dimensions of the windows. If it has 2,776 square inches of glass. Now, second, is it reasonable for the rectangular glass part of the window if the claim is about 30 by 70 or equal to 2,100 square inches and has enough glass for semicircle? So, literally speaking, if this design will be adjusted into 30 by 70, the situation talks about, do we have enough glass material for this semicircle? No? And for number three, suppose the length of the rectangular window is changed into 1.6 to 1. The area of the window glass is 2,822.4 square inches. What are the dimensions? So we are only talking. So literally speaking, this first situation and third situation is the same process. However, the ratio is changed because in the first situation talks about 2 to 1 ratio. Here, we're talking about 1.6 to 1 ratio. So to start with, we will be using the Polya's problem solving technique. What are the approximate dimensions of the windows if it has 2,776 square inches of glass? So first is to understand the problem. Let our unknown be the x as the width of the rectangular window as well as the diameter of the semicircle window. So 2x is the length of the rectangular window as well as the, no more, no? 2x is the length, by the way. Sorry for that. So the given is 2,776 square inches of glass raw material. So we know that the area, since we're talking about a rectangular portion and a semicircle, we know that the area of a rectangle is length times width, and the area of a circle is pi r squared. So when we say semicircle, it's half of the circle. So literally, we will just divide the area of the circle here. So next is to devise a plan. Our plan is to calculate the areas of the rectangle and the semicircle. So to do that, we have first length times width, which is equals to 2x times x, or it's, no, we substitute its value from the unknown. So we have 2x squared as the area of the rectangle. Second is the area of a semicircle. So literally we have half of a square. So 1/2 times pi r squared. Now notice that the diameter is twice of its radius. So therefore, the radius is actually half of its diameter. No? So kaduhaon ko na nato ang diameter, ang radius, that is a diameter. Kung kuhaon na to ang radius, so tungaon po na to ang diameter. This is half of its diameter. So substituting this relationship to this value here, we have 1/2 times pi times d over 2 quantity squared. So simplifying, we have pi times d squared all over 4. But notice, d is exactly the same as its width. No? So this is actually x. So multiplying numerator times numerator and denominator times denominator, we have pi x squared all over 8. Okay. Next, we have to carry out a plan. So in order to solve for the dimension of x, let us assume that they are all equal, no? So if we will add the area of a rectangle plus the area of a semicircle, that will be equal to 2,776 square inches. Now, we use square inches, and since we do not know this dimension, assume that the unit of this area of a rectangle and semicircle are in square inches. So let me remove na lang, no, this unit. Later on I will be discussing. So by this we have 2x squared as the area of the rectangle plus pi or x squared all over 8 for the semicircle, which is equal to 2,776 square inches. Now, notice that x squared here is common, so we will divide out, no? Or factor out. Factor out, not divide out. So the remaining terms will be 2 plus pi over 8 times the whole quantity of x squared, which is equals to 2,776. So dividing both sides by 2 plus pi over 8, we have x squared is equal to 2,776 all over 2 plus pi over 8. So this becomes a complex fraction. So simplifying first this denominator, we have to find the LCD. And the LCD is 8. So we will just multiply 2 by 8 over 8. Okay, 8 over 8 is equals to 1. So this becomes x squared is equals to 2,776 all over 16 plus pi all over 8. So this becomes a complex fraction. No, and simplifying this complex fraction, this is x squared is equals to 2,776 times the reciprocal of the denominator fraction. So times, we take its reciprocal, that is the denominator becomes a numerator and the numerator becomes a denominator. So this is 8 all over 16 plus pi. So simplifying, we have x squared is equals to 22,208 all over 16 plus pi. So notice this is still in inches squared and inches squared. So since we are talking about a dimension, the dimension should be in inches. So to get that particular dimension, we need to extract the square root. So since on grade 8 we don't have the square root uh, or radical topic, radical symbol, no? In grade 8, I would just like ask you to use your calculators there, no? So extract square root on both sides. Squared will be neutralized, no? So it becomes x now here in terms of x in inches form. And that would be equal to the square root of this whole part, no? 22,208 all over 16 plus pi. And we know approximately pi is approximately equal to 3.1416. Okay, this is an irrational number, no? It continues. Napanay continuation. So, di na to mahuman. So, since this is just an approximate, let us take its uh, decimal form into its nearest 10,000s, 20,000s. Okay, so this will be approximately equal to positive and negative 34 in inches, no? When we extract the square root. So here, we know that we don't have a negative 34 inches in reality, no? So we need to take the absolute value. So we take this positive value. Okay, ang square root symbol contains a positive and negative value. So the width, therefore, as well as the diameter is 34 inches. And since the length is twice its width, we have 64 inches. So if times 2 na itong 34, we have 68 inches. So to check, we have area of rectangle and area of semicircle, no? Pi d squared all over 8. We have 34 times 68, and we have pi times 34 squared all over 8. So we have 1,292 square inches. And approximately, we need approximation because of the value of pi. We have 454 square inches. Now, since this is now the exact uh, approximations, no? exact value of the rectangular window, and as well as the semicircle, no? We need to check from the given raw glass materials, no? We have area of rectangle plus area of a semicircle minus the exact, no? Exact glass material. We have 1,292 square inches plus 454 square inches minus 2,776 square inches. So there is an excess of 1,030 square inches of glass. So dako-dako pa, no? We have a huge excess of glass material. So for the case number 2, is it reasonable for a rectangular glass part of the window if it claimed to have 30 by 70 or equal to 2,100 square inches and has enough glass for semicircle? Paigo pa ba kuno kung ato i-change, ato i-adjust ang design into 30 by 70, not anymore 34 by 68, no? So let us try to check, no? So using the same situation in looking back, no? Length times width and pi d squared over 8 for semicircle, we have 30 times 70 and pi times 30 squared all over 8. So we have 2,100 square inches here. We have 900 pi all over 8, which is approximately equal to 354 square inches. So let us try to answer this second case. So area of a rectangle plus area of a semicircle minus the uh, given raw glass material of 2,776 square inches. We have 2,100 square inches plus the approximate value 354 square inches minus 2,776. The answer is yes, there is an excess of 322 square inches of glass. Even if a glass of approximately 354 square inches has been provided for the semicircle.